Hello friends, today we learn about the flip-flop in the SR flip-flop. SR means S means set, R means reset flip-flop. In the basic, the SR flip-flop can be realized using the Nand gate. It is 1-bit store memory elements. Here the SR flip-flops we construct with the Nand gate with the truth table. The truth table of the SR gate of the SR flip-flop is, the truth table of the SR flip-flop is, if the one input S is equal to 0 and second input is 0, so both the output of Q and Q bar no change. NC means no change. No change means if Q is provided 0, then answer also become the 0. If Q bar is equal to 1, so answer also become the 1. Means the no change in the output. That's why the output of the SR flip-flop in 0 input is no change. After then the input S and R is 0 and 1, then output is 0 and 1. Here 1 is the Q bar and 1 become the reset, hence output become the reset. Here S is equal to, if you provide S is equal to 1, R is equal to 0, then output of Q is 1 and Q bar is become the 0. So output here Q is equal to 1 and S is equal to 1, so outputs become the set. If we provide the S and R input, both are same, means 1 input. So here Q and Q bar they become the also the 1. So these both are output is Q and Q bar both are 1. This is called the invalid, because in the flip-flop output is always complementary. Complementary means the Q is equal to 1, so output Q bar is equal to 0, and Q is equal to 0, so output Q bar is always become the 1. That's why this statement is called the invalid statement. Now next, first of all step, if S and R is equal to 0. If S and R is equal to 0, if S and R equal to 0, so S is equal to 0, here S is equal to 0, R is equal to 0. So S is equal to 0, R is equal to 0. This is called the Nand gate. Work as an inverter. If S is equal to 0, R is equal to 0, then output of the Nand gate is S is equal to 1 and R is equal to 1. Here S is equal to R is equal to 1. First of all, here assume Q is equal to 0, because if any flip-flop output is depend the previous value, but previous value we cannot identify. That's why we assume this Q is equal to 0. This Q is equal to 0 is become the past this 0, so 0 and 1. So if any input is 0 in the NAND gate, output is always 1. This 1 is passed on this NAND gate, so both are 1 in the input of gate NAND gate, so output is always 0. So here we assume Q is equal to 0 and output is also become the 0, means no change in the output. That's why the if S and R both input are 0, then output is both are input are 0, then output of Q is not a change but same output. That's why the S and R both are 0, then output is always no change. Second condition, if S is equal to 0 and R is equal to 1. If S is equal to 0 and R is equal to 1. S is equal to 0, R is equal to 1. So S is equal to 0, the output of the NAND gate is 1. If R is equal to 1, the output is NAND gate is 0. If any input in NAND gate is 0, the output is always 1. If any input in NAND gate is 0, the output is always 1. This one is passed on. So both the input of 3 gate NAND gate is 1. So output is become the 0. If we pass this output is 0 here, then also both input is 0. If any input 0 in NAND gate, output is always 1. Here output Q bar is equal to 1. Here R is provided is equal to 1. That's why output is become the reset. Third condition, if S is equal to 1 and R is equal to 0. If S is equal to 1 and R is equal to 0. 1, then output of this NAND gate is 0 and output of this NAND gate is 1. Here if any input in NAND gate is 0, the output is always 1. This one is passed on this one, both the input is 1 1, so output is become the 0. And this out 0 is passed on this, so both the input is 0, then output is also 1. That's why here Q is equal to 1, here provide the S is equal to 1, that's why the output is become the set condition. The next and last step is if S and R is equal to 1. If S and R is equal to 1, here S is equal to 1 and R is equal to 1. So both the NAND gates output is become the 0. Then our condition is if NAND gate, if any input is 0, in NAND gate if any input is 0, the output is always become the 1. Here we see then the output of the both the flip-flop and NAND gate is both are 1 1. But in our condition, flip-flop output is always become the complementary. Q is either 0 or Q bar 1 is 1 or 0. But here both the output is 1 1. That's why in the SR flip-flop, gate 3 both the input is 1 1, both the output is 1 1. That's called the invalid condition of the flip-flop. Thank you so much for watching this video. In next video we see the SR flip-flop and JK flip-flop.